Hello guys, today we are going to Hello guys, today we are going to do the integral of e power of negative x plus 1 over x times square root of x from 0 to infinity. Here, you can see our square root of x. So I'm going to substitute its reciprocal. You know the reciprocal of square root of x, which is x squared. So I'm going to do something like that. You can see 1 over x here. So I'm going to substitute our x squared. You can see 1 over x squared, and then when you do the derivative of x squared, right, you can get 2x, 1 over x squared should be. When you do the derivative of this, first you are going to square this thing, and then do the derivative, put a negative sign, and then do the derivative of x squared, which is 2x. And then you can get x power 3 here. This x power 3 have a special meaning here. So I'm going to substitute our, which is x is equal to 1 over u squared u. And then do derivative, you can get our negative 2 over u cubed, right? And then we let x is equal to that, so our u is going to be equal to 1 over x, and then take a square root. So this 1 over square root of x. And then we pay our dx with our negative 2 time, put 0 into it, you can get our infinity. You should be putting in here. Put 0 into the square root of x, so this square root of 0, 1 over square root of 0 is infinity. Put infinity into this, you can get 0. And then e power of negative x, which is equal to 1 over u squared, and then 1 over x, which is u squared, reciprocal. And then u cube. What's our u cube in our x row? So you can get x is equal to 1 over u squared. What is u cube? So reciprocal both sides, you can get 1 over x, which is equal to u squared. And then u, which is equal to 1 over square root of x, and then take a cube of it, which is u cube is equal to our 1 over, I'm going to write this square root of x as our x power of our 1 over 2, right? And then I'm going to do the cube on one side. So we can get u, which is equal to 1 over x, and then 3 over 2. 3 over 2, you can write this as x power of 1/2 times x. So this is gonna be x times square root of x. So this is, just replace this. After that, you can just get this, something like this. After using the substitution. Like that. And then here, when you put a negative u sign into it, first thing we are going to switch the order. Switch the upper bound and the lower bound by this negative sign, so we can get something like this. And then I'm going to write the bigger term first, and then a smaller reciprocal. And then I'm going to put a negative u into this function, u squared plus 1 over u squared. When you take a negative u inside, you can get the original function back. Therefore, this is an even function. So we can write this as our 1/2 of that. 1/2. The integral from 0 to infinity of our f of x dx. The graph is like this. And this function need to concave. Yes, converge, not concave. Like this. Assume that this is an even function. Even, right? Assume that this is an even function. The integral from 0 to infinity, which is here. And then when you do the integral from negative infinity to positive infinity of f of x here, this is our f of x graph. which is just twice of that, twice of the area of this. Therefore, I'm going to change this as our, when you concave this, which is 1/2, right? This, which is equal to 1/2, multiplied by 1/2 on one side, so you can get something like this. Therefore, this and this just cancel each other. Therefore, you can get this u squared plus 1/u squared du. What should we do here? And then here, I'm going to compute the square. Compute the square like that, e power of negative. You have something like u squared plus our 1/u and then square. Therefore, the middle term gonna be 2 times u over 1/u. This is something that we add into it, right? Plus 2u times 1/u. Therefore, we have to subtract it. Subtract and then du. And then u and 1/u cancel. You can get e power of negative 2, right? No. I should not use the positive side because let me see what happens if you use the positive side here. So after computing the square, you get something like this. Parentheses u plus 1/u square. And then time minus 2 like that. And then you get something like e square. And then time this. And the e power minus this. This is just another integral. We cannot do anything about it. Positive side, because this is a positive side. We cannot use the identity. So we have to use the negative side here. So let me just do it here. This is 1, you can see. This should be, we should use the negative side here because we are going to use the identity. If we use the negative side here, there should be positive side, so this is positive 2. And then take a negative e power of negative 2 outside, so this 1/e squared. Then e power of negative u minus 1/u squared, like that. And then we can use our identity, right? We have a formula which is the integral from negative infinity to infinity of e power of negative, no, it should be f of x minus 1/x dx. This is equal to the integral from negative infinity of f of x. And this function needs to be even. So when you put a negative u, this always gonna be the same because of the square. So this, we can write this just our e to the power of negative u squared u. And this result, which is equal to our Gaussian integral result, which is square root of pi. So we can get our result, which is equal to square root of pi over e squared. And that's our answers. And thanks for watching.